All right. All right. So we're getting into exciting stuff now. Just to not warn you guys, but so when I took what we're about to get into, it was an 8-step process. I have made it into a 5-step process. And you're still going to gripe about it. I don't care. What we're getting into is when they say this has been clinically tested and proven, that word proven is sort of misused. So how do you clinically test something like a new toothpaste? What do you think it's done? Yes.
They select people to try it out for you.
I love it. They pick a sample. But that by itself is not good enough because you need what to clinically test a new toothpaste? You need a control group. And even maybe in this case it makes a little less sense, but placebo. So the control group is the one that continues as they are, right? Using their old, outdated toothpaste, right? And then you give the other group the new toothpaste. And sometimes you have a placebo group, but that makes a little less sense with toothpaste. Is everybody aware what the placebo effect is? I mean, that's like sugar pills. If they do just as good of a job as your medicine, then you might as well just take a little more sugar and be good with it. But it's more like the mental effect. We believe it will do something for us, and that happens because our brain actually makes chemicals and it's able to do things on its own sometimes. Anyway, so that's a cool little effect. So what we're going to start to get into today is how do I test a claim? So obviously, if I made a new toothpaste, my claim must be something about why it's better. If it's no better, what the shit am I doing making some new toothpaste? I'm like, there's already tons of freaking, holy shit, just let me get toothpaste, not 18 different types of crust. All right, sorry. Old man Jeff, you guys like this old man's ranting. So we're about to get in something called hypothesis testing. If somebody has a stance, what are they kind of fighting against? So if I believe my toothpaste removes more plaque than the other one, what stance am I fighting against? What am I trying to disprove then? If I think my toothpaste removes more plaque. Good. So I'm fighting against the idea that it does the same or worse. I love it. So the way I look at it is, the beginning of these tests, you have to state what your claim is, and then you have to figure out what the two stances are. I always think of these as two old men in a coffee shop talking about something. Has anybody ever seen old men in a coffee shop talking about something? Well, you should really raise this tariff. You're insane. So they always have opposite opinions, right? Very often. Not always, but most of the time. All right. So here's the idea. I'm going to do several iterations of this to kind of build up to the 5 steps. So let's go off of my, let's use what the hell? Let's do the toothpaste thing. So I make a new toothpaste. Right. So the old toothpaste, so this claim is my new toothpaste removes more plaque. So this is one hypothesis. What's the counter hypothesis? What's the thing I'm trying to fight against? Yeah, that my new toothpaste removes the same amount or less plaque. I like it. Let's make this a little more mathematical. Let's say that regular old toothpaste is known to remove 85% plaque. Right? So this is just the old toothpaste. So can somebody tell me mathematically what does my claim look like? Sure, I like it. So I'm claiming that my percentage, my proportion is greater than 0.85. So what's the other one look like?
Or equal to?
Or equal to, I like it. I like it. They have to be true opposites, which means together they have to cover everything. So if neither statement equals 85%, I've left it out. Two opposite statements have to together cover everything. I think it's going to rain today. I don't think it's going to rain today. Bam! It covers everything. What about snow? Well, that's not rain, so that's in there. Hey. You guys with me? Maybe. Okay. We're going to get a little more detailed into the distinction between these two and give them official names later. I don't care about it yet. I take a sample of people, like you guys said, and I'm going to hold them down and brush it down. Give them some of the toothpaste and let them try it out. So I take a sample. So right here, when I'm writing down my hypothesis and the alternate stance, do I know anything about the sample yet? Obviously not, because I'm just now taking a sample, right? Okay. You guys are like, oh shit, you guys are like, I know I'm gonna love this shit so much. Okay. Take a sample, and then I'm gonna let them brush their teeth, and then gonna measure how much plaque that removed, right? Just go with this. I'm not a dentist. I don't know what the flip I'm talking about. But still, basic idea makes sense, hopefully. If I take a sample and I let them use the new toothpaste, do you guys understand how just being bigger than this is not enough evidence that my new toothpaste is better? Let me see if you guys really get this. What if I get the percentage from my sample? It's a little pea hat dude, right? The little hat on that dude's gonna have a party. It's from a sample. Well, let's say I get 0.854. Is that bigger than 0.85? Yes, but why can't I just stop there and go, I proved it? Can anybody see why that is not enough evidence by itself? No, well, that's one thing. But why does it matter? There's always going to be somebody, I don't care how much I talk about what I'm talking about right now, that says, why do we do extra shit? That's bigger. Well, where'd that 0.854 come from? A sample of people using the new toothpaste. What's my claim about?
Population.
Everybody that uses the new, oh shit, so I'm trying to use sample information to infer some. Is it possible I just pick people whose teeth work with my new toothpaste really well? Mm-hmm. In fact, they're the only people in the universe that has a certain little tooth thing that my toothpaste works well. Anybody else, it would like remove 10%. These people, I just happen to pick them. All right, that's a little extreme, but you guys, anything could happen in a sample. You guys with me? So not only, please let this make sense, not only does my result have to be big, in this case, bigger than that, it's got to be bigger than that enough. So stay with me, this is really cool. I know these are P's, but we're going to learn, so let's see, that's the middle, 0.85. These guys, they think it's somewhere in here. Because like, right here, here's my 0.854 maybe, but I don't even know where it is really. Why can't I not even tell how far apart these are? I don't know the standard deviation. If the standard deviation is 0.002, those are 2 steps apart. Holy shit. But if the standard deviation is 0.1, and those are really close, See, this is one big thing I wanted to come out of everything we talked about before. Standard deviation is how we measure distance. So if I ask you, are these close? Coming into this class, you would have said yes. I'm hoping right now you realize, I don't know. Those two stars are really close to each other. They're millions of miles apart, but on the scale of how close stars are, that's close, right? Standard deviation is that feel for how close things are in general, right? Bless you. You guys with me? That's what standard deviation does. It's a measure of distance based on the average I get away from the middle. That's why I use it to measure how far things are apart. Okay, I like it. So this could be evidence that my toothpaste is better, but it's not yet strong enough evidence. Not only do I have to be greater than 0.85, I've got to be greater than 0.85 enough. Because if this is correct, where do I expect samples to happen? Somewhere in here. So I could get a sample way the shit up there, and that's usual. That's not unexpected. That's not unusual. So since I'm getting it from a sample, not only does it have to be bigger, it's got to be way the shit up here. It's got to be out here. Why is that tail I'm talking about on that side? It's kind of silly, but why? Because my claim is greater. Yeah. That's where I'm going to find evidence is above. See how I talked about before why isn't this a one-tail test then? I only care about there. If my sample's down there, I'm screwed. If my sample's here, I'm screwed. Sample's got to be just up there is the only place that shows evidence. So this is a one-tail test. And I got that T-score chart just waiting for me. Okay, how are we doing so far? We haven't done a ton. Okay, all right. So, before I start trying to use standard deviations and so forth, what would the next step be? What do I have to show before I can start to bring in z-scores and probabilities and stuff? What do I need to know is true?
The distribution normal.
Yeah, I got to have a normal distribution, right? So this would be the first step. And thankfully, it's not going to take as long as it just did, because right now, of course, I'm explaining all the frickin' steps. This is going to be a very short step. I might as well, let's finish this first step out. Second step is going to be, why the hell are you allowed to do this problem? And what are you going to use, Z or T? Okay. So let's finish this guy out. My two opposing hypotheses.
That's the first step.
Yes, this is everything we talked about. Can everybody up here see the two hypotheses? One is my claim, and the other one is the opposite of that. That's kind of like what I'm trying to fight against. No, my toothpaste is not just as good. No, my toothpaste is not worse. My toothpaste is better. Man. Okay, now. These two are called the Null Hypothesis. The symbol is H sub 0. Affectionately known as the hoe. Just deal with it. That little sub-0, we've talked about subscripts before. It's just a specific type of hypothesis, in this case the null hypothesis. And then we have the other ones called the alternate. And we call it, some books used to call it the ha, so I had the hos and the ha's. This book calls it H1, so it looks like the hos and the highs. So I'm just trying to, what math is trying to do is give us a little shorthand to talk about the two situations. Okay, I like it. Yes?
The book calls it the HA.
Oh, it does? Oh, okay. So I could call it the hos and the ha's then. All right, I like it. So we'll call it the hos and the ha's. I think it was the other book, the Triola book I used to use. All right. Let me see if I can lay this groundwork real quick. Do you guys notice how we haven't really done much of anything? But still, it's the whole idea behind it. Okay. The only way to show evidence that it isn't this is if I get up here, right? And why is it up here in this case? Because it says greater than. Right? So, which one of these can I show evidence for? Based on what I just said. I can never show evidence that something equals something else, ever. We've talked about that. If I take a sample of people and the average age is 24, does that mean the average age of all Grossman students is 24? No. But if somebody's like, I think the average age of Grossman students is 70. All right, take a sample, 24, you're screwed. All right, so I can show evidence against something equaling something through a sample, but I can't take a sample and show that evidence that it equals something, because the sample is almost always going to be not equal to the right thing. You guys kind of with me? A little bit. But I can take a sample. Somebody's like, I think it's up here. My sample's way the shit down here. I'm like, you're wrong. That's evidence that it's less. But I can't show evidence that it is equal to something. There's no way to do that. Okay, maybe. So which one of these statements can I actually show evidence for? Which one? This one. Why can't I show evidence for this? Because it includes equal to. So the one you can show evidence for is the alternate. And the one you can't is the null. What's the quick way to remember that? If it has an equal sign, you put it next to the hook. And then the other one is the other one. I do have a little worksheet I'm going to give to you. It's got all the steps explained on it, so you can have it sitting next to you as you're doing your problems. Can't use it on the final. Don't get excited. Okay, how are we doing so far? So that's really what the first step truly looks like, is just this. Bam. So is this a one-tail or a two-tail test? We already talked about it, but it's obviously going to be one-tail. What do you think's got to happen for it to be a type of test where it's a two-tail test? No, careful. Yeah, confidence intervals are two-tail situations, but it's not a two-tail hypothesis test. Let me just tell you. If my claim was it doesn't equal something, how can you not equal something? You can either be more or less. That's two tails. So the only way to be two tails is if this was not equal to. If it's greater, one tail that way. If it's less, one tail that way. Okay, I like it. So let's do another problem just on this step before I go to the next steps. Because we don't have to, I don't really need to live with this toothpaste thing. Do another example of just the old man in the coffee shop. Which one's the hoe? I don't know. You gotta talk. So let's say I think the average SAT score for people who drink a lot of coffee is not equal to 875. So here's what I normally do. You write the claim using symbols. So using statistic symbols and numbers. What is it that's being claimed? I'm not going to use the symbol P because that's a percentage, and this is not a product percentage. What symbol am I going to use? Not X bar. Think about it real quick. Not to pick on that, but I get a lot of people do that. I'm never going to make a claim about a sample because I can see it. What's X bar? I know what it is. Mu. Because I don't know what that is. If I just take a sample, I have no idea what mu is, but I can make a claim about it, right? So what's the claim? Mu not equal to
75.
875. So could anybody tell me which one does that go into?
Well,
Beautiful. Why? Because it totally does not have an equals. It's got the opposite. In fact, what's the opposite of this?
it's
Equal to. So that's got to go here, because what's the thing about the hope? What's the thing about the null hypothesis? It's got to be the one that's got an equal sign. That's the thing that's going to keep you straight. So the claim could go either way, but my claim doesn't have an equal sign. It's got the opposite of an equal sign. So my claim goes here, and then this is going to be the opposite person. I like it. How many tail tests would this be? 2 tail. There's not a directional thing. I don't care which direction you go. I just got to be far enough from 875 to show evidence that my claim is right. This would be 2 tail. All right, let's do another one. I feel like the percentage of people who like hypothesis tests is at most 42%. Try to do it yourself. Write the claim and then figure out HO and HO. So what you do is you write the claim, you put it in the right place, and then the other place is the opposite. You gotta remember what the hell at most means. Yeah. Symbol are you going to use? Symbol, not a word. What symbol are you going to use? Mu or P?
Absolutely.
P, okay. So what's my claim?
Less than or equal to. Less than or equal to.
Less than or equal to. At most is less than or equal to. And like I told you before, you always make a percentage into a decimal before you start doing shit with it. So you guys, that happened to you on the test. And that's why you got you needed 180 million people. Holy shit. Take those percentages down to decimal, yeah. So where's that go? Where's that claim go? Which one? Oh. I'm sometimes like, are you saying O or O? Okay. So definitely here. Why? It's a freaking equal sign. So what's this going to be? Greater than. So how many tail tests? Where's that tail going to be?
That way. Greater.
Yeah, greater. Now notice something about hypothesis tests. The test itself don't give the first shit what your claim is. If I succeed, if I find a sample out here, and this is me, am I happy? If I find a sample way the hell out there, which means this guy is wrong, it's evidence for this guy, am I happy? Which one is me? Which one is how I feel? I feel like, yeah. The null captures my claim, right? So do I actually want to find evidence against this? No, I'm kind of secretly hoping I fail this test, believe it or not, because that would mean I haven't shown evidence that I'm wrong. All right, I know know I'm getting a little deep right now, but still, all this test is able to do is show evidence for or not enough evidence for this. So when I was rooting for this to be true, let's find evidence. Over here I'm like, hold on. So this is how science works. I think this. Let's go try to disprove that shit. So if we really think that, we're kind of hoping it doesn't disprove it. But if it does, we get excited because we're like, we're wrong. It's something else. What? Freaky. Right? This is the thing people don't understand about science. Science doesn't give a shit about what people believe. It just gives a shit about what it is. Right? And if it isn't what I thought, I'm happy. I'm like, whoa, I was wrong. What could it be? Anyway, sorry. A little rant. Sorry. Do that a lot. How are you guys feeling so far? I mean, that's the first step. Write the claim in symbols. You can really easily tell which one it goes in for. The other one is the opposite. Whatever this guy says is where the tail's going to be. Yes?
What are the possible symbols that could go
Oh, okay.
to the P?
What we're going to have time to do is it could be mu or p. And to be honest, there's a test we could do about standard deviations that we are more than likely not going to have time to get
So
into.
those are the three.
Those are the three biggies.
So mu is if you don't know.
Yeah. So do you see how this is? What are the things I could calculate from a sample? They all relate to the things we could not know about the population. So that list is longer than that, but it gets a little weird after that. Those are the three big ones that you do at the beginning of statistics. Yeah. Any parameter that exists, you could have a test to see. There's another it's sort of like mu, but it's like the difference between two things. So I could do a test about if I make a new weight loss program, I want to show that the difference in weight is bigger than something to have, so I can have a commercial. It's been clinically tested. So I don't know how to do it. So there's another one that's the difference between two things. I can have a test for that. Okay, I like it. Anyway, so these are the two we're going to have time to do, I think. Yes?
I'm just kind of confused about when to use each one. Like when to use B and when to use P.
Joey?
Average. Oh, okay.
And Joey. Yeah, okay.
Okay.
I'm sorry, I don't mean to make it, but
Oh, no,
it is.
okay,
It's
okay.
gotta be. It's gonna be really, really obvious if you just know what to look. Am I talking about percentages in this case, or am I talking about means, averages in this case? And that tells you which symbol to use, which will also then tell you what formulas to use. Here, I'm gonna want to use formulas that got mu in it, and there I probably want to use something that got p's and q's in it.
So it's standard deviation, like one of the ones we'll use because it's right next to the P.
It is, but notice how it's not boxed up.
Okay,
So we could do hypothesis tests for this. We will talk about, all right, since we're talking a little bit about it. What tells me how a normal curve is shaped? Skinny versus fat. What is it that tells me which one? Standard deviation. So if I wanted to get a picture of what all the standard deviations look like, it probably doesn't look like this because this shape is governed by a standard deviation, right? So if I plot all the different standard deviations, it actually looks more like Jabba the Hutt. It looks like, wow. It's got this big ass, it goes, oh, big ass tail. Oh, right? Oh, soda, So that's going to be chapter 12, if I remember correctly. 11. 11 is what's called chi-square. It's nothing to do with Dragon Ball, sorry. Yes? Yeah, those are always going to be skewed to the right. But we'll talk about it when we get there. We're not there. So for this guy, at least on the surface, do you see why he's by himself? Both of these use the normal curve. Because for both of them, you can calculate the standard deviation. What does standard deviations look like? Different, obviously. It should make sense that they're not going to be the same because this shape is made by the standard deviation. Oh, shit. Okay, enough of that. These are the two we're going to worry about. Okay. Second step is old news. That's the first step. Second step is old news. Second step is, look at that, we got a new fable. What am I allowed to use? So let's see what we got. The first step is all about the hose and the hogs. The second step is Z or T scores. Zort. So we already know how to figure that out, right? What are the two things I'd have to check for this step? Two things. Same two things you got to check for confidence intervals before you go start to use shit. Two things. What tells me I can do anything? So I got to check to see if it's normal. If it ain't, I can't do shit. If it is normal, how do I tell which Z or T?
It's a sample line.
True. But how do I tell you Z or T is which what do I know? Which standard deviation I know, right? If I know sigma, it's Z. If I know S, it's T. I don't know if you guys picked up on this. How many confidence interval formulas are there? Oh, shit. 3. Right? There's 2 with X bar in them. Why are there 2 with X bar in them? There's one with Z, and one with T. And then there was a third one. So if you have an NPQ problem, if it's normal, you use Z scores, period. If it ain't normal, you don't do shit. And why is that? Because with NPQ problems, we create our standard deviation. So effectively, we always know it. Here, it's which one do you know? So when you have an NPQ problem, the question isn't Z or T, it's just Z or nothing. Bless you. That was weird. Oh. All right. So that's step 2. It's the old step. Step 2 is the same step we had to do on the test several times. Verify you can do shit. Is it normal? Normal enough. I like it. Now the third step is where things get interesting. Third and the fourth step are the 2 most important steps. It doesn't mean you can just not do the first 2 because you said they were the most true. They are the heart of a hypothesis test. So, for example, this right here. What is it all about? If I found a p hat that was 0.43, can you just stop there and say you found evidence? No, why not? It's got to be not just more than 0.42, but it's got to be way more than 0.42, far enough away. So step 3